live. Welcome everyone to our Fireside chat about the best first coding languages for students. My name is Joe Mazzone and I teach at Davies Career and Technical High School in Rhode Island. So high school teacher. And I'm joined with some really great guests today for us to have an interesting conversation about programming and your first experiences learning programming throughout different grade bands. So I'm going to have our guests introduce themselves first to kick it off. Audra, would you like to start?
Sure. Hi, everybody. My name is Audra Kaplan, live from Connecticut. I am a middle school digital literacy and computer science teacher, 5th and 6th grade. And we just kicked off our vacation on Monday, so I'm pretty excited to relax a little and explore lots of tools.
Excellent. Professor Austin Cory Bart.
Hi, my name is Austin Cory Bart, or I guess Professor Bart. I am an assistant professor in computer information sciences at the University of Delaware, where I've been for 3 or 4 years now. I've been studying how people learn computing, particularly early introductory education at the undergraduate level. And I've made a bunch of tools and done research in that area for a few years now.
Excellent. Neil?
Hello, everybody. My name is Neil Grand. I'm a 5th year computer science, high school computer science teacher. Prior to that, I worked in the finance industry for many years in the world of hedge funds. I was a coder for many years, so I bring that experience into this classroom.
And Sam.
My name is Sam George. I'm a tech founder and CEO of Gridbyte Incorporated. We are a management consulting, engineering technology firm. So my background is, my formal training is in electrical engineering and mathematics. And along with that comes a significant amount of coding in my in my life. So that's my background.
Increasing more and more. I've been having some conversations with the local universities about the electrical engineering majors are kind of shifting more towards computer engineering and a lot more coding involved. It's just the natural way our world is kind of going right now. So I hear you there, Sam. All right, so welcome everyone. What we are going to be looking at is we're going to start at the younger ages, and we're going to talk about what do we think as this group, and feel free to please comment those that are watching, and I'll read those comments aloud. I'm not sure if you guys as guests can see the comments. It may kind of block out that area. There should be someone that said hello. So you see it there?
Yep.
Excellent.
We see
Perfect.
that.
We can all see the comments. We've had troubles with that before, but we can all see the comments, so please comment. And so we're going to start off with younger learners, you know, those maybe elementary age students, or, hey, my son just is 15 months now, a little over 1 year old. As soon as he's reading, I'm going to start. But what are the best experiences for these younger people to start to learn programming? Anyone can start if you have an idea, something you want to think about.
Well, there definitely are lots of things to choose from, more and more jumping in as time goes by, but I can talk a little bit about some of the stuff I've done with elementary kids. When I used to run the Hour of Code, we had an ambassador program, and the high school kids would actually train and go down to the younger levels. And we did some stuff on the iPads with Hopscotch and Lightbot. It's been a while, so I'm trying to remember these, making a little list. The Keibos are also a little fun. It's this little robot, and you have these blocks, and when you put the blocks together, you insert the blocks into the robot. It performs different functions. What else? A lot of unplugged activities we would do. I'm a big fan of Google Apps, so I would often make grids with characters, and then the kids would use just drag and drop arrows, you know, to try to build a program, and then their friends would test it, and they would swap and try out each other's code. That was a bit of fun. Dash and dots we've used quite a bit. I don't know if you're familiar with those. They have block coding and text-based coding. The younger kids especially, I think, like to really get their hands into stuff to try things. So having physical devices they can manipulate and play with is great, especially using imagery like arrows and turn symbols for the kids who are, earlier pre-readers.
Yep.
Those are a few. I don't know if any, I have more, but I don't want to hold stuff. If anybody wants to jump in, I can come back in a minute.
Anyone else have some thoughts? So yeah, Audra listed some really great tools that are out there, and I think some of the conversation that I was thinking about having at this point was this idea that there's some of them that are purely digital interfaces as we would be used to, mainly block drag and drop coding, right? But then there are these other devices that I would think is interesting in the research world of learning code, where these physical blocks or instructions or puzzle pieces that young learners can put together to kind of make these algorithms to move a little robot or do something. Anyone else have some thoughts around this? Yeah.
I would like to offer some thoughts that I think are a lot less helpful, but come from sort of the research side of saying the answer to your question from my perspective is, oh, we don't know. Like
Yeah.
we can offer a lot of ideas, but as a research community, I don't think there's a lot of actually very clear answers on what does and does not work, strictly in terms of trying to increase students' cognitive understanding. Like we can point to very specific things and teach very specific ideas. You look at CS Unplugged has been effective in some small, very localized ways at teaching certain concepts, not necessarily better than using a screen, but for especially younger kids, not a whole lot of research yet, especially nothing definitive. That said, I think that the major value is not necessarily in the cognitive realm, it's the motivational and just exposure. And just that's what a lot of that research focuses on, is finding out like, okay, these kids may have never thought about doing any of this stuff. And if they get hyped about moving blocks, if they get hyped about a little robot mouse that they can guide through a maze, if they get hyped because it's Minecraft themed, then whatever gets them hyped at least is some kind of victory. It's some kind of exposure to these ideas, and it probably can't hurt. Certainly, I'm very interested in research on learning trajectories that people are establishing to try and say, like, certain fundamental ideas that come early, like the idea of sequence, right? As programmers, a lot of us take for granted the idea that, the first line of code is executed, then the second line of code is executed, and the third line of code is executed. That's actually a big idea for a little kid, right? Like when you're tiny and young, you don't necessarily think in that way. Events happen and they happen, but there's not necessarily the cause effect, the play, the story that's unfolding. And if I have a student in my class at the undergraduate level who doesn't have that idea, it's a lot harder to teach them the basic stuff that I want to cover. So there's some idea of progression. I think the research community is starting to nail out a little bit more. And I think that's a really exciting thing that we don't really understand yet.
Absolutely.
Yeah, if I can add, and I kind of talk a little bit about the elementary and the middle school, kind of segue it together. I found that what kids really like to do, two things. They love animation. So if you make something of a movie, and I'm thinking about Scratch and I'm thinking about p5.js, which I'll talk about at length. And also the kids love, at least some of the kids, all the way from the youngest age, all the way through high school. I teach primarily high school. They love making games. So anything that you can do that makes it seem like it's a game, it goes a long way with kids. With Scratch, kids love making games. If I tell them that they have to make a game, they're working on it in school and at home. If I tell them they have to create something like a maze, they're really into it. Any kind of shoot 'em game, they're into it.
Sam, you've done some workshops, correct, with some youth in your area?
Yeah, so we have a couple of initiatives. The big ones are to pull in the interests and skills of what we call twice exceptional children. These are gifted children that have learning differences.
Mm-hmm.
So we're actually doing more and more work in that space with 3E children. These are children from disenfranchised or other communities. It's been interesting in the sense that we've covered a very wide range. So my background usually is at the university level and the professional level. So it's been interesting to try to scale that down to meet students, younger students, where they are. And what we find is, or what we found so far with these different workshops is a big range of responses to different types of programming. Some kids you'd think would naturally gravitate towards Python or whatever it is. They don't. it's a very hit or miss kind of thing, which is why I was interested when Cory mentioned, this forum. I thought, okay, well, let's see what other people's experiences are. The question for me now is just when we frame this question, what language is best for starting or beginning programmers? The answer is that I don't know. I don't think we know. We can say Python because we all like Python, right? It's great. But is it the best language for programming? I didn't start with, I started with BASIC, right? So it dates me right away. For the longest while, I programmed everything in BASIC until I got to college, actually, when I started, and then they taught us Fortran in those days, right? And then we went into C++, and sort of the migration is from there. Would I start a younger kid on Python? Surprisingly, the answer could be yes. Because our experience with the kids the last couple of weeks has been that they seem to pick up the syntax, and also they surprised us in some interesting ways by being willing to read the documentation and Google things and come back with really innovative ways to solve problems. So that could be, the block programming methods didn't really work well. It was like, okay, well, we've done this, like, what else can we do? so that was a very, that's a, opening thought on what language is best for kids, or for younger people, or starting program or beginning programs.
Yeah, if I might add, for middle school kids and even for high school kids, if I kind of take the trajectory that way, a language that was developed a few years ago is created at NYU called P5.js, which is JavaScript, but it's in a framework of using it on an online editor, and it's very animation driven. So kids learn the basics of using how to create variables, how to do if then else logic, how to do loops, and everything they do, they can see it on the screen. So they can create a ball on the screen, they could create all kinds of geometric shapes, and then within a few days, they could be moving an arrow across the screen. They could have two balls coming from two different directions and hitting and then reacting to it. The same way you can do it in Scratch, but it's more programmatic. In Scratch, they have wonderful features for younger children, so that if two sprites come together, they have commands that say if they meet, then bounce off of each other. Those kind of things, the visual effects, the students seem to love it a lot. There's something that I created for the kids. It's only a few lines long. Using those concepts plus the random concept, they could have balls bouncing all over the place, changing shape, changing color, and creating a really nice effect. And it's only a 12-line program.
Absolutely.
So if I could add some thoughts, and I feel like I'm going to be doing the same thing I just did and just being a wet blanket and everything, is I wanted to just sort of comment from the academic perspective of first of all, how useless the academic perspective is, in particularly like, the vocabulary and the terminology that we get fixated over in academia. Like, P5.js is it's not a language, it's a library, and we talk about block interfaces. Well, you can have Python with a block interface, right? Like that's one of my tools is BlockPy, which puts a block interface on top of Python, and you can do the same thing for Java or for anything. The Scratch compiler, like its underlying thing that runs the code, is separate from the interface writes the code, and all of that is by way of really saying is that we have no clue how to actually make languages, and I don't mean for kids. I don't mean for undergraduates, I mean for adults. I mean for people who use languages. If you look at most programming languages, they were tossed together with like a lot of good intentions, in some cases a lot of thinking by very smart people, but not things like, say, user research or by actually studying how people think and how people want to use them. I have this research friend, Dr. Andreas Stefik, who I love his research. It's just so cool because he does these studies about how people use programming languages and he tears them apart. He's vicious with some of these results, finding out that the people using Java is just, it's not a very intuitive language. Perl, super unintuitive language. Even languages like Python and Ruby that we love, like they have so many ugly bits about them. And people haven't studied this a whole lot. Like, we don't know how to make languages for adults. So anyone who comes to me and says like, oh yeah, you know, best language for starting is Python or Racket or Java, man, you don't know. It's whatever works for you, that gets you excited, that gets you programming. And the context, this is what you guys are talking about, is making games. If that's what the kids like, then let them make games. If you get hyped about music and, you know, arranging sampling and doing that kind of thing, and you can share that energy with your kids, do that, right? Anything, and if it can translate into things, transfer things like, you know, business coding, text processing, data science, that's great too. That's a whole other avenue of motivation to tap, is authenticity and usefulness. But for younger kids, I think just focus on getting them hyped.
Yeah, so I think that's really interesting, and I had a feeling when we set this up that was the direction we were going to go, because I kind of know it's that it's really what we do with these things that is most important, in getting students excited. Now, I think we may come back to younger grades and kind of talk about that again, but I'd like to address David's question in the chat here, because and it also kind of wraps into Lisa's question or comment. And I see teachers talk about this a lot. Is it, and I think this is more of a concern of the high school teachers. I hear this a lot from high school teachers. Is it better to kind of dig deep into using one language so students really feel comfortable? Or is it important to expose them to multiple languages throughout, let's say, a pathway of courses that students may take? What are our thoughts?
I'd like to address that as a high school teacher. I actually feel strongly that it's better to learn one language. And I'll give the analogy. If you learn 1 year of Italian, 1 year of Spanish, and 1 year of French, and you go to the middle of Europe, you're not going to be able to say that much. But if you know 3 years of French, you're actually going to do really well in one of those countries. So I'm not a great fan of the different language approach. I mean, I understand the thinking behind it, but what I'd like to do, I like to get my kids, just because most high school kids are either considering the Java AP test or thinking about the Java AP test. Java is the deep end, and it's hard. But I like to start them in Java and then take them as slowly or as fastly as they want to go. Now, I find that when I teach my curriculum, in any room I've ever taught in, there's kids learning at all different paces. And there are kids literally at lesson 3, there are kids literally at lesson 9, and there are lots of kids flying and lots of kids having issues. And I'm doing a lot of tutoring, and I'm finding that a lot of kids are tutoring other kids. And I find that the most productive way to teach, to let everybody learn at their own pace. And if we could get to a world where kids have multiple years of a language, then they really can begin to think algorithmically using that language. And I use this analogy. I think that when you play chess, for example, and I'm a big chess player and I have been my whole life, you know, at the beginning it looks kind of hard how to move the pieces. But once you get kind of used to the moving the pieces, knowing how to play the game is completely different from knowing how to move the pieces. I want the kids to begin to think how to, and I'll use this by analogy, how to make checkmate in 1 move, and then to get them to make how to checkmate in 2 moves, and 3 moves, and 4 moves, and to get them to be check, 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 checkmate. And I want them programmatically, using programming languages, to begin to think as much as we can how to think algorithmically, so that you're almost language agnostic, but you're thinking. The kids are thinking and figuring stuff out. I position my course as problem solvers and problem articulators. The language could be whatever, whether it's Python or Java, or it's VBA or Excel or Wix. A lot of these problems have the same kind of issue to it. But if you can get them to figure stuff out, you're on the way. You're on the way to having them do really cool things, and having them do projects where they're doing fairly complicated things and enjoying it.
Yeah, I think that you know, the one language model works to a point, and you know, it's one of those languages have strengths and weaknesses. So You know, sometimes I think in computer science classes, we used to joke that, well, you know, we're studying C++ today because the professor likes it, not because it's useful to us. Because I wouldn't choose C++ for the majority of my program, my professional work. I don't choose C++. The overhead is too high. So in most cases, actually, we're doing a lot of you know, advanced coding in Mathematica or MATLAB, because that's, you know, I come from the data analytics. That's what I'm doing now these days in the world. So using R, which are more high-level languages, where we're not interested in writing low-level code. We're interested in solving big problems with you know, with more developed libraries, routines, and things like that. So, you know, it depends. I think that it depends on what resources are available, right? If you know, as a teacher are good at, you know, a certain language, then that's what you teach, and the students will either, you know, love it or hate it, right? It's just one of those things. It's hard to say that, you know, because you could finish, you know, with Python and say, well, it's not great, it's not solving all my problems, then what next? You know, I choose a different language for a different job. So anyway, it's just throwing some thoughts out there.
Yeah, one of the things I try to emphasize to my students, because I teach high school, is that I want them to begin to think about how they might get a really cool and interesting internship, either in their high school days or in their college days. And if they can come with some practical knowledge, that is usually really helpful. And I can tell from my own children, my own biological children, that coming with this kind of background is very helpful. My teenage daughter just told me today that because she knows how to develop websites using Wix, she got the job. They like looked at that and they were like, this is amazing, you can do that. And Wix is a very simple program. But the fact that she's mastered it and she's ready on day one to use it, puts her in a totally different league against the other kids who she's competing with to get an internship.
Yeah. I don't want to dominate. I just want to sort of add to that is that I think it's important we get straight our goals and what we want to try and do with these different age groups. If you're talking about a high schooler internship, even undergraduate, they may have a very job-oriented focus. When you're talking about like undergraduates and some of the more advanced classes, I'm trying to train them to be not someone who can go to Spain and live there for a few years, but a linguist who can know many languages. And I think to evolve into the full computer scientist, whatever that means, that no one can tell you, no one knows what that means. But it probably involves learning a lot of different languages. But you can get a job just knowing Java. You can get a job with a lot less than knowing Java. You could half know Java and get a good job nowadays. So I think there's a lot of different goals, and what people want, making sure that we align ourselves with their goals and letting them know that there's other things out there, right? Like some of our goal is to get these kids into the class and become the linguist, the computer scientist who learns all those things and then teaches the next generation and is like, you know, advances the field. For a lot of them, it's just trying to get them a job that pays, you know, good money and puts food on the table and has stability. So we need a lot of different things. And I strongly agree with everything you've said, though. Like everyone's saying really good things from my perspective.
Yeah. One of the things I'll mention from my perspective is, so people ask me often, why do I do so much with Python? And previously I was teaching a lot of Python, like multiple courses with it. And the reason comes back to the curriculum idea we were talking about and the things you can do. And so Python is still gaining a lot of popularity. It's being weighed as very useful, you know, for a lot of job seekers. So it's checking that box also. But it was just so easy because so many libraries that exist and so many cool things that you can do with Python when it comes to physical computing, with you know, many things on the Raspberry Pi easily done with Python, as well as MicroPython being available. When it comes to doing graphics stuff, you know, such easy ways to do that. Students could explore so many different interests so easily and learn so many different great programming concepts. So,
I'm sorry, Joe, go on.
So I just have one more thing to say is, so why am I all of a sudden teaching Java at the end of this pathway again? Well, after a couple of years of kind of doing this just Python thing, I realized all of a sudden that switching to a language. Students were going to university and they were starting off with either C++ or Java at most of the universities, it's their first course. And some of them, although they said, yeah, no, I was able to switch, there was a little bit of just syntax things and stuff like that that they almost just became not aware of because I was so Python focused. So just teaching the AP Computer Science A at the end of their journey with the supports from me that knows the journey that they had before that, I was able to transition them so much smoother, and now they were able to be exposed to other languages just by knowing 2 different ones with me. They're able to transition to other languages so much easier. But go ahead, Neil. I know you had something to say. And Audra, I want to follow up with you too.
So, as I said at the beginning, I'm a career switcher. And when I worked in the world of finance, when everybody was thinking about what language to use in the world of finance, overwhelmingly, the decision was to go with C++, C#. That was the language of choice because in the world of business, at least, the libraries that came with it were considered amazing. Even though Java comes with great libraries and Python comes with great libraries, it was by kind of unanimous acclaim, the choice language, which was C#. I'm not to say that people didn't use Java and Python, but C# kind of took a front seat. And that was admittedly 5 years ago, but they're all competing. So whatever Java is doing, C# wants to do as well. Just like the difference between Google Sheets and Excel, they're always competing with each other. They're always trying to steal each other's thunder.
As David said too, and this was some of the issues that I experienced, David, there's so many Pythonic ways to do things that when you switch to another language, and let's say you're just like so strong in Python, you're like, why can't I just do it this way? So I found that a lot with some students and that's why I think a lot of people do C++. If you do things in C++, that kind of seems to transfer easier to other languages. Audra, what are some of your thoughts there?
Oh, sorry, Audra.
So I'm down at the middle school level.
Yep.
I see kids for about 45 days, and I do digital literacy and computer science. And like some of you have already said, I'm trying to get the majority of them excited about it who are new to it, but I always have a handful of kids who can run circles around me already. So I try to introduce the languages I use with my 5th and 6th graders right now are Scratch and Root. Root has a simulator. What I like about Root is it codes in 3 different levels. So there's a visual block for pre-readers. You can transfer to level 2, which is hybrid like Scratch. And then you could go up to level 3, which is text-based. And it's all drag and drop, so there are no syntactical errors. To get kids started, I think that's exciting. Obviously, they'll need to understand that stuff and know that stuff as they get older. And my ultimate goal is to share a few different options with them and then have a project at the end of the course where they then pick the tool they're excited about and develop something to share back with the class.
Sam, what were your ideas here?
No, there was an interesting thing about language choice. It reminds me of these multi-language compilers and so on. So in some ways, that's another way to look at, language choice. You need to become competent in programming, right? Some language, doesn't really matter. The basic skills are, the same things everywhere. Yeah, you may not be able to do garbage collecting or some of these advanced function with one versus the other. For engineering particularly, we tend to choose certain types of programming languages just because we need horsepower, right? So we go much lower level. So I'll actually write more C code from scratch because it gives me the fastest execution of so far of all the different tools that we use, multi-threading or whatever it is. So, so I think for younger kids, the thing is what inspires them to come back and use a program. That's how I would define success. At least that's how we are defining success at this point. Are they intrinsically motivated to come back and use these tools? Because then you've had success. So far, what we see is most of the kids come in and they do a bunch of things, and then it's like an afterthought. They don't really internalize it. They don't come back. They don't remember the methods, and so on. So if we were to maybe standardize on or find some tool from some language to teach younger kids particularly, it would be something that should, and I'll put it out there as a question, what is the tool that most engages them intrinsically to want to come back and solve some of their either gaming needs or whatever? Do we have a point on that?
I'll add to that also, and question everyone here. Is Audra's idea the important piece to this, especially in workshops like Sam's running, that the students build to this project that they care about more? Is that an important thing? The more open-endedness. Professor Bart, you have some thoughts about this for sure.
Yes, I mean, the most valuable thing you can do is get a project that you care about, right? Like I have a whole curriculum that's full of these little activities and exercises, and they all pale in comparison to when a student gets a hold of a project that they actually want to do and put time into, and that they want to email me during winter break and say like, look at this thing I've made. It's a text adventure game. And I remember those projects myself. I didn't get to be a computer scientist by doing Code Academy and doing little logic puzzles and stuff like that. I did it by making a stupid website that scraped the dining halls, and by having a calculator that I could use for algebra class. Like, it's 100 stupid little projects like that that build up that competency, and it all comes down to being intrinsically motivated. And that can come from many places. It can come from, the native interest that you have in coding or in the context surrounding it. Or it could come from the idea that this could get me a job one day and it's a valuable skill. It could come from, my friends value this, so I want to do it too. Like, Jenny over there is also a coder, and I like working with Jenny, so I better take this class with her. Wherever these sources of motivation come from, if they're intrinsically there, like, so much more powerful, so much more learning happening. It's great when we can, that's our biggest job as teachers.
And David said something over here about robotics, and I've seen this too before. Some students maybe aren't interested in creating applications and websites and these other things, but they may be very interested in learning coding just specifically for working with robotics. And that's cool too. And so definitely interest is an interesting thing. David also mentions that he's had more, it seems like a quick read of the comment, more success with some of the block-based environments when it comes to that, probably because of this, memorizing, some of these commands as part of the libraries and stuff like that. So much easier to focus more on the problem at hand, just dragging out some of these blocks, than maybe memorizing some of those things. I don't know if, has anyone thought about that with blocks? What are some of the positives, negatives?
I definitely think it's.
Oh, you muted yourself instead of unmuting, Audra.
I think definitely with my 5th and 6th graders, with the exception of a handful of kids who probably have been programming for years already, the block-based really gets them excited. We also use the root robots, and I use Makeys, and now we're using microbits. When they have physical things they can manipulate as well, that just takes it to another level. Yeah. Gets them really excited about it.
Yeah, the physical computing has always been a thing I love, because I first got into the technical world from an electronics standpoint, and then later trying to make websites was my first adventure in programming, and then I was like, I want to do other things. But I find students enjoy that also.
From a goals perspective, we also have to ask this question. I think today our national imperative is to raise, maybe tenfold of computer scientists and programmers, and so that's a different strategic imperative, right? That's an imperative that needs us to pull in a lot of kids who are not, quote, tech-minded. So that's the difficulty I think we're facing now. So we have to find languages and ideas that hook in kids who are linguists, for example, right? Maybe they want to do natural language processing or something that is not really code-based, but it is a programming, and so we have to find those opportunities, because that's where I think the that's where the 90% is going to come from. It's easy to find the 10% of kids who are tech-minded, right? Those kids, yeah, maybe, you know, once they find the right language, they'll gravitate and just move forward. But finding other kids who are not inclined towards the tech world or inclined towards STEM is what the challenge is. The last time we had a kid whose aspiration in life, he's I think in 3rd or 4th grade, is to be a judge. And so his mom dragged him to class to experience, you know, this coding world. And he goes, I don't want to do this, you know. And I said to him, well, you know, actually, maybe you don't want to do this, and I'm not going to force you. But actually, judges who understand tech are actually the most valuable thing today in America, you know, profession in America, right? So, and he kind of warmed up when he could see the connection. Right, and that was really good for him, because now he can see, oh, this is how judges. I talked to him about algorithms, how judges use algorithms to make sentencing fairer, and how. So he got that, right. He got that immediately, and that was the hook for him. And so I don't know. Maybe we take a step back and we ask the question: what's the strategic imperative, right? And how do we solve that problem? That's the problem. Anyway.
I really like that, and it takes me back to when my wife was first learning to program back. This is, you know, when she was an undergrad, and they taught her something that, you know, it's like Scratch. It was moving a kangaroo around a screen, and she was having fun with it at first. By the end of the semester, and they were still doing this kind of stuff. She's an undergraduate animal science major, and she's like, what on earth do they have me doing? Like, this is obviously not real programming. It's such a waste of my time. And that really stuck with me. And when I was putting together my first class, like, the emphasis, you know, there was some fun stuff, but there's also a lot of stuff that we wanted to be useful for non-majors. Things like data science type things, working with data related to many different interests. And I think that's a major thing when you look at older students who have a bit more career in mind, a bit more focus for their lives, that you find ways to make it useful, authentic, and practical. So I really like what you said there, Sam.
Yeah, I mean, just along those lines, one of the projects that I did this past year was that I had the kids go to the UN website, download various kinds of data, and then and this is at the beginning level, have them calculate according to UN statistics, according to their data science, what are the happiest countries in the world and what are the least happiest countries in the world. And it's like, oh, and what country what number is our country? So I agree with you. It's an interesting question, how to make it relevant, how to make it fun. And it's always a challenge. I've always found it a challenge that there's kids, all kinds of kids, and there's all kinds of levels of interest in terms of computer science.
Yeah.
And if you think about elementary kids and elementary teachers in general, they have such a wide span of things they have to teach, and that can be a bit of an issue too when trying to introduce computational thinking, computer science, in terms of the teachers being prepared, confident and competent in what they're teaching. That's going to make a big difference with the kids moving forward.
And back to Sam's idea, I think that's one of our biggest barrier I see is preparing enough teachers to feel confident to cover these skills. When we talk about a K-12 strategy, or, you know, introducing kindergarten to 12th grade here in the States, is definitely getting enough teachers to feel confident. We have it, Audra and I, you know, very involved in CSTA, presidents at our CSTA chapters, and we see that we're trying to help a lot of teachers that are new to CS. Maybe we're teaching something else, or we're just chosen at their school to be the brave person, and we want them to feel confident and be able to learn as much as possible.
I'll rudely interject a thought there and say, like, I think that it's a difficult problem to train teachers who don't have coding experience, but it's not that much more difficult than training kids who don't have coding experience. Although granted, now there's a whole pedagogical element. That paying teachers more, giving teachers more respect. Let's make sure that we keep track of the elephant in the room, that all the education problems, you know, surrounding things make that a lot more difficult. If we paid them more and we gave them more time off and, you know, treated them correctly, it probably wouldn't be quite as hard as we make it for ourselves.
You're absolutely right. For sure. Treating teachers a bit differently than, let's say, you know, they are treated or thought about often would help people join the profession. One of the things before I think I'd like to bring up this one thing that I was just having a thought on. that kind of brings us back to the block environments. And then I'd like to just kind of talk about the beginning of college, and we did start to think about that, and I believe that we're gonna have the same conversation. It's really about what they're doing more than what the specific language. But can we have a small conversation? Why is Scratch so popular? What is it about Scratch or particular block environments that makes them so popular?
The fact that you can click the run button and it just immediately does things. It's hard to make programs that don't do anything. It's got fun graphics. Am I missing anything? What else is there?
It's one of the first big block-based languages, right?
There's also like literally millions of projects that you can essentially inherit from, so that you don't ever have to start from scratch when you basically search within their website and you say, I want to know what a maze game looks like. When you type in maze, you get hundreds of maze games to choose from. It is a really fun environment. I find that after a few sessions of teaching it, the kids are off and running. And I say, do something that's going to make me, you know, say, wow, that's really great. And a lot of kids rise up to that. I mean, it's just a lot harder to do that in Java. I think the P5.js is just a much easier approach to do the kind of wow stuff that you see in Scratch. And P5.js is harder than Scratch, so it'll never get the same traction at the beginning, but it's taking you along the right path.
Neil, so you know, I just built the coding rooms people a template for P5.js. So if you are, you can start using that there soon enough.
Good to know. Thank you for that.
Go ahead, Audra. I'm sorry to interrupt.
Oh, that's okay. I was going to say, I actually learned programming on COBOL many years ago, and became a teacher, and that was behind me. So I'm really back in the game now the last few years. But Scratch was like a go-to for me. It's pretty straightforward and simple. You can make really fun, creative things pretty quickly. And the kids really, in my experience, gravitate to it. They have a lot of fun with it.
But you know, I will add, if you don't know anything about Scratch and you don't have anyone to teach you, it's very exasperating. You actually need some instruction. You need to do some thinking about it or being instructed, or else you look and you go, what is this? Why is nothing working?
I've seen that with people, and that's interesting. If anyone has like more ideas about that, because I remember, and this is years ago now, maybe 10 years, I don't know how long Scratch has been out, maybe it was 10 years ago. And I remember like being like, oh, this is cool, and just clicking and making things, and like this was really cool. But I've seen individuals more in the past 4 years maybe, where they are unfamiliar with it. These are people that know how to program, let's say maybe doing something else, and they get Scratch in front of them. They can't use it at all. These are adults, not students.
Yeah, they have some sample programs in there which are very, very good. So if you start with those and look at the code there, that would be the way to go. But not everybody can intuit that.
Right.
Yeah, why is it not intuitive? Yeah.
Well,
Professor Bart.
So I was a coach for a while with technology, and I think adults are just hesitant when it comes to new technology if they haven't tried it before. And the kids just jump in. They don't care. They're not afraid to try it. Yeah.
But maybe it depends on their backgrounds too, right? So for people who are engineers and computer scientists, it's second nature. So the question: what type of adult are we talking about?
There's no such thing as intuition, right? Like there's only just prior experiences, and we mistake intuition for you have more prior experience in this particular thing. If you've seen something vaguely like it before, it helps or it hinders in some cases, right? Like if you have a certain idea of like what a variable is and you bring that to something like Prolog, boy, you are in for a bit of a surprise, completely different language model, and you're put out there. I just wanted to say though that when I look at things like learning like how to use Scratch or anything else, it's not easy to get tossed in with a project, even if someone gives you examples. That's not really enough. I think there's a lot of low-level skills and ideas that a guided curriculum, I made fun of Code Academy earlier, but I have a lot of respect for the way they walk you through this concept and that concept. And I model a lot of what I teach with automatic feedback and things better than just unit tests, and trying to look at the student's code programmatically and say things like, you know, you need a for loop here, all that kind of stuff. That is very powerful in that it can help build up those little skills, build the confidence, and let you get to the point where you can make the big projects. Because that will never get you to be a computer scientist or a software engineer. You can't just learn to code by all that little stuff. But you need it to help you figure out how to open up a blank text document and type code into it, or open up a new Scratch window and just put blocks in there. You need both. You need both of those things.
I guess this completely makes sense with, I've seen, you know, professionals with just different developing environments, different IDEs, right? And they only use you only have your prior experiences. So if this IDE has things in places and is designed to be used a certain way that you're not familiar with, you're lost completely on it. So it's that familiarity.
Well, I think also avoiding, you know, Scratch is good because in a way it avoids the syntactic problems that come along with learning languages, right? That's a big deal for most of the students we see, right? And most of the times when we're coding, when we're watching over their code in, say, coding rooms, is really like, oh no, you didn't put that tab in that place, you didn't put that semicolon over there, and that's why you missed. So that ends up being extremely frustrating for a lot of students, and Scratch avoids that to some degree, to a large degree actually. So that's something to keep in mind.
And that's what's really cool about, so Professor Bart, I'm going to have you talk about BlockPy a little bit. And the reason why I started using BlockPy to start off was I wanted the advantage of the block languages, but I wanted to be smoothly transition to Python. And I didn't want them to have to worry about the syntax. And I also wanted them to have the blocks be a way to visualize the syntax of Python that uses white space. But Professor Bart, can you talk about your project a little bit? Because I think it's a superior way to think about leveraging the blocks environment.
I always love talking about myself and my research. The BlockPy environment, as you say, is a dual block text program environment that lets you do it side by side. Anything you do on the block side, reflect on the text side. Anything you do on the text side, reflect on the block side. If you've seen pencil code, there's a lot of other things that do this now. And I think it's a really good idea because it removes a lot of the barrier from the syntax. Because as you mentioned earlier, it's like that's a hefty barrier to put in front of people. And the funny thing, I was giggling in my head a little bit talking about Scratch being like special compared to Python or Java. It's not. The environment is amazing, but the language could have been more like Python or Lua or Java or TypeScript or C. It doesn't matter, right? Like, because it's the library, the fact that there's a little cat on the screen. Well, I can do that in Python with Pygame, and I could put a nice convenient layer on top, and that's what BlockPy does, right? Like, it puts a layer of blocks, and the students in my class that use BlockPy, we transitioned them out of the blocks after like 2 weeks, right? And like, they don't want to be in the blocks, most of them. I have students every semester. There's one student who lives in it to the very end of the semester, and you know, no judgment there. It's just, I tell them, like, my goal is to really get you writing the text because that lets you type faster, and that's what most professionals are going to expect you to use. But the idea happens pretty naturally to my perspective, and the syntax isn't necessarily the hard part. Right, like it is a hard part, it is a barrier, but compared to the logic that goes on with once you understand the syntax, that's much harder, and that takes a lot more of my time thinking from the research perspective. I think someone wanted to say something I just said though. No? Okay.
I was going to ask a question since I'm going to poke the researcher a little bit. It always bugs me that we're still coding, programming, not coding, is still a text-based operation at the end of the day. Good. And it's, you know, sort of, you know, I keep looking at it and going like, you know, yeah, this is a 50-year-old technology, right? We're still looking at, you know, running VI or, you know, Emacs, or, you know, at the end of the day, I program in Linux a lot. So those are the, you know, I'm always, you know, messing around with text editors, you know, and, you know, what can we do better than, you know, coding in text? And actually, block programming is interesting. It's an easy entry point, but it also has very strict limitations when you talk about passing variables and doing more advanced things. So So that's kind of where I see the dichotomy. Kids fall off very quickly out of block programming, and then it's like, well, it's full on text or full on text. There's nothing else in between. And, you know, I don't know, it's just as developers and creators, you know, why are we programming in a 50-year-old, you know, type of text-based tools or paradigm?
Why do we drive on the right side of the road to the left side of the road? You know, it's a good question. It's a valid question. And I know some people who would vigorously shake their head yes right now, being like, heck yeah, you're absolutely right. You go to Blocks and Beyond, the major block-based programming conference, and that's what they talk about there is like, why are things like GP and Snap not the dominant programming model? I mean, I had a little bit of data at one point. I never really got to prove this in any scientific way, but it seemed like you could write programs more quickly with BlockPy's blocks than text. Like just the sheer amount of code you could get onto the screen was faster because of the blocks. You drag over a for loop block and you get more characters per second. And it better reflects the underlying abstract syntax tree, so it's technically more accurate. Mm-hmm. But text has certain advantages apparently, and I don't know if it's momentum or anything else, but here we are. It's a good question.
Well, you know, and with some of the intelligent autocomplete that many of the editors have, you know what I mean? I think you end up having text can outperform, you know, the speed with someone, you know, even though one drag and drop, just you can dump in a bunch of code depending on, I mean, we could make a block have a ton of code, right? Behind it. But it's still, I wonder how the thought process goes when you drag out a block to represent something versus thinking through the individual lines as you're building something. Let's say like, you know, a loop and it has these method calls in it, and you're kind of thinking out in that very linear sequential kind of sense. I'm not sure.
Yeah, I think that my students really like Coding Room because the autocomplete, like you were saying, it minimizes the number of errors that are done. The typing errors and particularly in Java, there's an issue with beginners with capitalization. So when you say import java.util.scanner, like, what do you mean you have to capitalize scanner? And those kind of questions, having a helping hand there is useful. And it does take some of the frustration out of the process.
For sure. Or a complex project where you have number of variable names, having, you know, them pop up on your screen what the heck you used, and not having to memorize if you did some camel casing and if capitalized a certain way, etc. Certainly helps us as you're building an advanced project. Just as a quick thing, because really I wanted to be able to get to this, but we had such great conversation. Students entering college, because this is a highly debated thing all the time also. Do you, you know, I see most of the time Java, C++. First year programming class, that's what it has to be. I teach AP Computer Science A, it's Java. Most of the schools my students go to, it's C++, and they get the course written off. So they get into a second level course and it's C++, and they're expected to have known it. Most of them succeed pretty well. And we all know it's because the professor chose the language, really. That's the only reason. But some of these professors have really are passionate about, no, it has to be C++ or it has to be Java for X, Y. Can students at starting university just learn Python or JavaScript? And, you know, what's going on with that?
Sure, they do all the time, right?
Yeah. Do we have thoughts about, you know, should we start pushing more against these college professors and saying, hey, it doesn't have to be C++?
Yes, we don't know what we're talking about. I mean, they won't like that I'm saying this, but I don't think that anyone who tells you the best first language is X, they're a fanatic. And I love Python. I think the right choice for the first language is Python. But I can't lie to you and tell you that I've got data that proves it's a better choice unequivocally in all circumstances than Java or Snap or Racket or any of the other reasonable choices. Certainly, if you came at me with something like, I don't know, Algol or Munge, there are wrong choices, but there aren't that many of them. I don't know. That's me.
Maybe there are choices that align with the, you know, whatever the goal is that you're trying to do, right? So again, if you're doing, you know, high-speed embedded code, you know, there's certain paths you go down, right? It's just natural to choose. Actually, not even C++ in that case. C++ carries too much of an overhead for me, so I tend to go more in C in that sense, right? Because these libraries need to be very fast because they pump a lot of data, and we don't have time, right? So we tend to do things a certain way and not carry the overhead. But yeah, it really depends on what you're trying to do and what your objective is.
Well, and I love that idea, Sam. And Professor Bart, you brought this up too, talking about your wife. But when we talk about CS majors, non-CS majors, what's our focus here? Is the language really important, or is it the content and what you're able to do with that? Do we have thoughts on that as our last kind of parting words?
The content matters a lot. Motivation matters, right? So those are critical things to think about. I think Python is a great tool because it's all runtime, so it's it removes a lot of the barriers for entry. So that's a big deal.
Yeah, I would chime in, and I agree with you that thinking algorithmically is the important thing, and which language you use is a secondary effect. I mean, the language is important, and each language has its pros and its cons, but actually trying to get them to figure out problems is, for them, a much bigger challenge than once they figure out how to do it algorithmically, how to program it.
You can always ask, how do you do this, right? If you have a solution in your head, like, okay, or you see the student, like the other day, the student was cutting and pasting, and I go, what are you trying to do? They're trying to build a fractal, and I go, okay, well, there's a smarter way to do that, right? So that's at least, but so you can always ask questions. How do I do this? How do I do that, right? And improve from there. So.
And that's when I've seen transitions from one language to another, or a particular library even, those are the important questions for a student to ask. And the autonomy that someone just mentioned in the comments there is they'll say, well, I know you can do this. I want to know how to do it with this. And having those experiences and the exposure is what develops that thinking. Is knowing things are possible, because that's often the thing that's demystified, I feel like, in my classroom, is showing students that certain things are possible and that they're able to do it. They may know, oh, someone creates, we know that the X social media app exists or X thing exists, but they can't fathom the idea of them creating it. Giving them little building blocks helps them visualize how something like that is created. Any parting words from anyone?
Neil, I wanted to give you a thumbs up too on thinking logically, because that's really, at the end of the day, what we want to teach students, right? It's not the programming language. It's really understanding a concept, right? How do you think and structure a program from an executive perspective to say, okay, this is where I want to start, think sequentially, this is how I want to, kind of build it in my head, and then maybe diagram it, right? Go through a flowchart. These are sort of basic engineering skill sets, right? You go through flowcharts to figure out how you're going to solve a problem. Then the rest is, left is an exercise, right? At least because you've solved the problem. You've actually made a logical sequence of operations that you can use to address the problem.
Makes sense. That's why the computer science standards emphasize so strongly from kindergarten to 12th grade, sequence, selection, and iteration. Knowing those three things and how to start to think with that can help you solve, well, supposedly, what's the law there, or theory, that those are the only three constructs you need to solve any problem?
You're talking about lambda calculus and Turing completeness, and I'm blanking on the other idea that would fit perfectly in there.
Yeah. All right. Well, thank you, everyone. Thanks to everyone that watched or is going to watch the recording. Thank you, guests. You were absolutely amazing. And I really enjoyed this conversation, so thank you very much.
Thanks, everybody. Nice to meet y'all.
Thank you,
everybody. Bye-bye.
Thanks, Neil.
Very cool.